So good morning. Thank you very much for the invitation to come and talk with all of you and meet all of you again. So today I'm going to talk about some topics which I think I'm very passionate about and very excited to be back here at the AIT. The picture that you have here, you see here, is from about 4 years ago when I left as a professor from the AIT and started a company. And these were the graduates from the AIT that for a while we were 100% AIT alumni. I think there are not many companies that can say that they're 100% AIT. So since then, we've been working in this area of data analysis, data visualization, and I think it's a very exciting domain, and I'm very happy to share it with you today. So first of all, I think we're all very familiar with the growing importance of data and this what has been called the data economy. And I'm going to talk in particular about some of the areas which I think are actually quite challenging and where there's a lot of opportunity for continued work between industry, academics, and research. So I think you've heard this saying before, that data is the new oil. And the idea that the data economy is really around this. We can see this increasingly in our use of devices. The mentions earlier about the Internet of Things. There's so much potential around the ability to take this data that's available and then turn it into something which is useful and valuable and helpful for making decisions. And the software that is really at the heart of that is to make it into useful data is part of that is data analytics. And so we look here at some of the problems that are there, the use of data analytics for exploring the data, the history of what has happened, what is recorded. We also have the growing problem of real-time data, so monitoring what is happening right now and being able to make timely decisions so that you can quickly respond or make valuable changes as things are happening. And another area which is of increasingly growing importance is prediction. So prediction it's not new that this is important, but what is I think the trend here is that the technology and the algorithms, the infrastructure is all coming into to become readily available to make predictions something that can be used within organizations in a very timely manner. So I think that these three, the past, present, future, what I put here, is really quite accurate about the sort of the progress of as a company as well. So I think many companies, many organizations, first of all, have this problem of trying to understand what happened, right? Recording of, generation of reports, and gathering this data to understand the history. It's another thing to get to a level of maturity within an organization where you actually have real-time data. We're able to look at what is happening today and to take that historical data and make history only 5 minutes ago. This is a real challenge, I think, from it's in industry in general, but certainly in most organizations. And then the idea of how you would actually build something that can guide your decisions in a very accurate way for prediction, I think is really what we see as the future. So what you can see here is these are different types of data that are typically seen inside of industry. And this comes from a TWI report. This is looking at basically from interviews with different companies about what they see. The pink is what they are using today. The part that's in the middle, the light gray, is what they plan to use in the next 3 years. And the gray is no plans, and the other ones they're not familiar with. So what I think is interesting here, you see the part that's in the light gray is where you can start to see some things that are really changing quickly. So one of the largest here is mobile data. You can see it about halfway down. See the big difference between what has happened in the past, that people are starting to increasingly use mobile data, mobile data platforms, but companies are really starting to look at how to use this data, how to access and be able to make this data valuable as the platforms for generating mobile data become more common. But certainly what we see on the top is the history of data management is primarily on the top part, the structured transactional data. The use of text data is a little bit further down. This is another area that's extremely important. But real-time data is still something that is a bit elusive and outside of the grasp of many companies. So here you have the types of analysis, and you can see, again, the part that's in the white. I think we understand what is the current state, the pink part, but what is in the future we see in the white. And the number 4 there, the predictive analysis, is really one that is, a lot of companies see the incredible value that accurate, effective, timely, predictive analytics can really provide, is something that is very enticing and exciting in the industry. So I think we can all see that. The part that's here towards the bottom, the text analytics, is still something that has been around for a very long time, but still it's difficult to get started with this in this area and to make use of it. So I think that I'll go through a number of slides that just to give just an overview of the terrain of the data marketplace. So I think people have heard before the big the V's related to big data, and so we have by itself in small amounts, data is not very intimidating. It's very simple. But once you start having very large volumes, or that it's quickly changing, rapid change, or that you have a huge variety of data in different forms, and then the concern of how accurate the data reflects reality. These are where the challenges in this domain occur. So some of the basic building blocks, the research in algorithms is where I see going from the research in academia to applications in industry. I think this is one of the really important connections, opportunities for collaboration. So this is looking at just some of the popularity of different types of data-related research topics. This is in software, an API is a way of taking an algorithm or process and making it something that's reusable. And so APIs are increasingly being valuable and useful and open. So we can see here is Amazon. Amazon has really moved from being an e-commerce player like all the other ones to being something which is really dominating in the area of the internet and the use of APIs and being able to use the data that they're generating. I think this is it's a really fascinating way that they've made themselves so critical in the infrastructure of the data economy. Some of the platforms. So we see that there's in this area of data economy, there are a lot of different areas, technologies and kind of software platforms that are relevant. So there's the origin of the data, the combination of the data, the provision of analytics over top of the data. And then there's also the platform for reuse of the data. This is the Gartner Magic Quadrant. I think that many of you may already be familiar with this. It's looking at the marketplace inside of business intelligence, data analytics, and dividing it up into those players who are the ones that are dominating the market, so who have the ability to execute on the y-axis, and on the x-axis are the ones that really have something that's visionary, but may or may not be able to actually complete or implement that vision. What we see is here, there's a combination here of different years. So Microsoft, Tableau, and Click are really up here in the top of being able to both set the direction of this market, and then also being able to deliver in that. And what you see here is Tableau really dominating at the top part here, as being something that's a very easy to use, simple to use, and quite powerful platform. But this is really in I would say the historical data analytics part that I mentioned. Moving into the predictive analytics, it's an entirely different ballgame. This is a description of some of the platforms that are used to make data accessible and usable by a very wide audience. So these are open data platforms, and they're used in many different domains. This particular research project is from Germany, but it's based on CCAN. CCAN is one of the most commonly used platforms in e-government projects. This is just a screenshot of Tableau, as I mentioned earlier. Very simple to use. It's a very good example. Tableau is a company that was established from researchers from Stanford who left, and most of them come from information retrieval, data visualization, and human-computer interaction, and went in and created this company that shook up the marketplace because of their simplicity and easy to use drag and drop type interface. This is an example of, from text analytics primarily, looking at the LexisNexis platform. And I thought it was a nice demonstration of the huge variety of different types of information that they are bringing together through this process. So we can see this funnel to a number of different tools that allow you to make decisions and understand what's happening inside of text-based documents. So a number of different domains. The technologies I'm talking about are very general, and data is everywhere. So we really see opportunities in many different marketplaces, and many of the topics that are being discussed here in the conference. So some of the big topics are education, transportation, consumer products, electricity, oil and gas, and healthcare, and consumer finance. So in the energy sector, certainly this is a very important area, and some of the projects that I'll show quickly are around energy and energy data. So focusing on the sort of the topic of this group, the collaboration and innovation, I thought it would be useful just to talk very quickly about the experience that I've had in both sides of this. So first of all, going from the academic side to industry. Very fascinating and exciting transition to take what we learn or teach in academics and then try to apply it in the real world and see how successful that is. And so when I created the Start company, we focused in data visualization in these different markets. Scientific data, environmental scientific data, energy data, and also some health data. And then we've also come back to the AIT looking for expertise that we don't have internal, and that's in the applying research domain. So yeah, as I mentioned, we created this company about 4 years ago, focusing in data visualization. And I just want to show a quick video about what we've produced. So this is a project we did for the UN that was released about a year ago, and then the most recent version, it just came out, was presented to the international community just 2 weeks ago. So this is a web-based platform. You can access it on your mobile phone, but I recommend it on a desktop actually. So I think what's novel here is the interactivity, right? So it's a web-based application. It's very simple. No software is required. You just load it in. It's very responsive. Once it's loaded, you're able to explore the domains of data very quickly. It's using different research from academics that we see quite commonly in management of information, presentation of information, this idea of facets, being able to drill down very quickly. It's, I think it's one of the, this has become an area for maintenance of policy documents to understand about the, try to understand correlation, the relationships between lead and lag indicators inside of energy policy in the Asian region. So this particular portal assembles a lot of data, socioeconomic data and energy data for all the countries in Asia, looking at the underlying data that reports the different types of usage of data, different types of energy that they're using, and then also the policies from each of the countries that have led to the change over time. This is the thing we added recently, is the mapping technology. I think that's, so these are looking at the infrastructure to encourage countries that have similar, the energy supply, it doesn't follow borders. So looking at opportunities for countries to collaborate over the borders for different sources of energy. So just real quickly, so we looked at some of the examples of maps, trade flow maps, infrastructure maps that drill down and see details of different areas. We looked at data maps, forklift maps that are overlaying data. We look at being able to drill down interactively into from the overall region to the details. Comparisons, these are called Sankey diagrams that allow you to interactively understand the flow of information from in different parts. This is a project we did that's looking at health predictive analytics. So we have data that we collect from the CDC in the US that looks at the incidence of outbreaks of different types of diseases. And then we look at the historical data to visualize the predictive, where there will be outbreaks in the countries, in the states. So the map on the top, it's a little bit, we've modified the map to make it easier to see the equal area for each state. And it's quite nice when you look at the flow of this map. So this is what we've done in applying the research that we have from academics out into developing software. And we've also relied on maintaining a relationship with AIT. One of the examples is in image analysis. We continue to work with Dr. Matt's lab in computer science where we use images for detection of DNA and the amount of different toxins in the water. And for this, we have a robot that is being deployed into the water outside of Seattle next week. In a project we work with NOAA in the United States on that. So it's a robot that monitors for the kinds of toxins that are in the water for like shellfish poisoning, those kinds of things that are extremely critical in the health management. So that's it. I really appreciate your time. I think the areas of data and the different domains that data can be applied, it's a very exciting and challenging domain, and I think there's a lot of opportunity for collaboration, certainly in many different areas around this topic. So thank you very much.